Thinking and communication problem for rational functions. C8. Determine a possible equation for a rational function with the following set of properties. Zeros at -1, vertical asymptote along the line x equals to minus 1.5 and x equals to 4, removable discontinuity at x equals to 2, and horizontal asymptote along the line y equals to 1. So this is a part of a test. Try to copy the question and then do it yourself. And once you have done the problem, look into my suggestion. Well, there could be more than one answer for this, okay? Now, let's start doing it. Determine a possible equation for a rational function with following set of properties. So let's say, let the rational function be f of x. So f of x is equal to zeros at x equals to minus 1. So if there is a 0 at minus 1, let's first make a line here. So we have something in the numerator, something in the denominator. Zeros go in the numerator, correct? Minus 1 means x plus 1. So that gives me a 0 at minus 1. The second is vertical asymptote along the line x equals to minus 1.5. Well, minus 1.5, I deal more in fractions. So minus 3 over 2. I know most students like decimals, right? But minus 3 over 2 means minus 1.5, correct? So if I write x 2x plus 3, right, as a factor, so this 0 in the denominator will be at minus 3 over 2. So that is the factor for minus 1.5. Well, one can write x plus 1.5 also. Okay, let me write it as 2x plus 3. I'll tell you the advantage of this. Vertical asymptote along the line x equals to minus 1.5. So I'll write 2x plus 3 and I will not write x plus 1.5. Okay, I'll give you the reason. Now here we have this factor 2x plus 3. That is one vertical asymptote. Another one at x equals to 4. That means x minus 4. Correct? Yes. Removable discontinuity at x equals to 2. So that means I have to extend my line further. Removable discontinuity means that there is a common factor in both numerator and denominator, which will cancel out and will give rise to a whole, which is a removable discontinuity. So removable discontinuity at x equals to 2 means the factor is x minus 2. So right here x minus 2. Now horizontal asymptote along the line y equals to 1. So for horizontal asymptote the degrees should be same, but in our equation degree is not same, right? You see numerator is degree 2 but denominator is degree 3. To make degrees same, what we can do is we can make this as a square. Do you see that? It doesn't change any of our condition. Zeros remain at this, right? So maybe when the problem said zeros, it means 2 zeros at minus 1, right? Maybe. So it's kind of a hint to a student to put 0. 2, multiplicity 2 of the 0, right? Okay. Now how will I make horizontal asymptote of line as y equals to 1? So at least I got the degree of numerator denominator same. So I'm looking for same ratio, correct? So ratio here is, if I multiply x and x I get 1. Here 2x, x I get 2. So for y equals to 1 I should multiply this by 2. Now I have a horizontal asymptote which is along line y equals to 1. So that is my answer. Okay, what I was saying was if, okay, you use 1.5, then your equation would have come like this in the denominator. It will be x plus 1.5 times x minus 4 times x minus 2, and here it be x plus 1. Hopefully you also put 0 square here, x minus 2. Now if you see it, you will think, well, x, x and x, that means x, x, 1. You will not put this 2 here. Do you understand? And that is a mistake which students who are using decimals will make. They will miss on this 2 and lose 1 mark, right? So it is kind of important to write it in fractions. Okay, I hope you understand and get the point. Thank you.